studied about number system. So what are the different types of numbers you have known? The first one you have studied about natural numbers. So what are these natural numbers?
They begin with 1, ma'am.
Begin with 1. So how you define these natural numbers? How you define these natural numbers? Counting numbers are called natural numbers. Suppose when you are counting any objects, how you start counting? Will you start counting like 0 or -1, -10? Will you start counting like that? No.
No,
You
ma'am.
will start counting only by starting with 1. So that counting numbers are called natural numbers. Counting numbers are called natural numbers. So you should remember this very well, children. Counting numbers are called natural numbers. And how we denote this natural numbers? This we are denoting by capital letter N. Natural numbers are denoted by capital letter N. And how we represent them? With flower bracket, you can write 1, 2, 3, 4, 5, and you can just go on writing this number. Which is the last natural number you can write, children? Which is the last natural number you will get in natural numbers?
Don't know, ma'am.
So that we call it as infinite. You can write infinite numbers. There is no end for numbers. If you write any last number, you can again get the next number also after that. So there is no end for this numbers. Okay. So counting numbers are called natural numbers, and natural numbers are denoted by capital letter N, and that we write it as 1, 2, 3, 4, 5, etc. to infinite. Infinity you can write the numbers. So that we call it as natural numbers. And this about natural numbers you have studied in your lower classes. And next we'll move on to the next type of number, that is whole number. Whole numbers. So how do you write this whole numbers?
The whole numbers start with 0, ma'am.
Very good. So whole number starts with 0. How you can define this whole numbers? So you can define whole numbers as 0 along with the set of whole natural numbers are called whole numbers. 0 along with or 0 added to natural number set also you can write. 0 along with collection of natural numbers. Collection of, or you can also write it as set of natural numbers. Natural numbers are called whole numbers. Are called whole numbers. Okay, children. So how we this whole numbers? We denote a capital W. Whole number set is denoted by the letter capital W. And how you write? You observe the definition. What we have written? 0 along with the collection of natural numbers. What are the collection of natural numbers? 1, 2, 3, 4, 5, etc. Up to what is the last whole number you can write here? Which is the last whole number you can write, children, here? It is infinity. You can write the numbers up to infinite. So we say 0 along with the collection of or set of natural numbers are called whole numbers, and that are denoted by letter capital W, and that is equal to 0, 1, 2, 3, 4, 5, etc. up to infinity. Okay, so this is all about whole numbers, and about this whole numbers you have studied in your previous class. And next we are going to discuss about integers. Integers is how you define this integers, children. What are
Ma'am,
integers?
group of negative and positive numbers, ma'am.
Yes, very good. So it is a group of or a set of positive and negative numbers. We call it as integers. It is a set of positive numbers and negative numbers along with zero. The collection of, or you can also call it as set of, or you can also call it as group of positive and negative numbers along with zero are called integers. And how do we define this integers, children? Integers are denoted by letter capital Z. This is the letter we use to denote integers, capital Z. And how you denote this capital Z integers? That is the numbers you can write from minus infinity to like minus 3, minus 2, minus 1, or along with positive numbers, negative numbers, and with 0. So 0, after 0 what we get? Plus 1, plus 2, plus 3, and etc. up to plus infinity. So this is how we denote the set of integers. So integer z, that is denoted by minus infinity to plus infinity, whatever the numbers we are getting, that we call it as integers. Understood, children? So this is how we denote integers. And about this integers you have studied in your 7th standard. So you have studied about natural numbers, whole numbers, and also about integers. Whatever you have studied about this natural numbers, whole numbers, and integers, so the same things are going to be repeated for this numbers also, whatever the properties you have learned. So that all will be repeated. Understood? So up to here, whatever we have discussed now, everything you have studied in your lower classes. Now, so how we can represent these numbers on the number line? We'll see how you have represented these numbers on the number line. So to know about that, we'll be just taking one line. So here I'm going to mark some numbers. Here I'll take, so whatever the numbers I'm taking, so that is, here I'll take 1, 2, 3, 4, 5, 6, 7, 8. And here also I'll take 1, 2, 3, 4, 5, 6, 7, 8. And here again I'm taking plus 1, plus 2, plus 3, plus 4, plus 5, plus 6, plus 7, plus 8. And this side I'm going to write -1, -2. Sorry, wait. Okay, so first we'll discuss about the integers and then we'll move on to whole numbers and natural numbers. Okay, so first set what I have written here, it is set of natural numbers. How you denote this natural numbers on the number line? Number line, when you are denoting natural numbers, it starts with 1, 2, 3, 4, 5, 6, 7, 8, up to infinity. You can go on writing the numbers. This is how you denote or represent natural numbers. And when you are representing whole numbers, set of whole numbers, what number should be added here for set of whole numbers? It should start with set of
Zero,
whole
ma'am.
numbers should 0. Yes, very good.
Zero,
So
ma'am.
0, 0, 1, 2, 3, 4, 5, 6, 7, 8. So here whole numbers, it starts with 0. Next, I'm going to write about integers. So integers, what is the definition you have learned? Integers means it is a collection of positive, negative, and along with 0. Here if you observe, what are the numbers we have, children, here? This all we call it as positive numbers, and here we'll write 0, and along with this we have negative numbers like -1, -2, -3, -4, -5. So these are all we call them as negative numbers. So this is how we denote a set of integers. If you observe the number line, we have on this number line positive numbers, 0 and negative numbers. Positive numbers are there, 0 is there, and negative numbers. So that we call it as the set of integers. So children, this year you are going to write NMMS exam, and in that you will be given so many questions are asked based on only these three number lines itself. So we'll discuss some questions based on this number line itself now. Now if you observe, can you tell all natural numbers are whole numbers? Understand the statement I am saying? All natural numbers are whole numbers. Can we tell
No,
like
ma'am.
that?
No,
No,
ma'am.
ma'am.
All natural numbers are whole numbers. Do you get all natural numbers in whole numbers group or not?
No, ma'am.
No, ma'am.
No, ma'am.
Because here it is
Okay.
ma'am.
Okay. One more point I'll explain you, children. Now whole numbers we have written. What are whole numbers we have? 0 and what is this 1, 2, 3, 4, 5, 6, 7, 8, whatever we have written here numbers? On whole number line, just observe whole number line, whole numbers number line. What does this part indicates? 1, 2, 3, 4, 5, 6, 7, 8. What it indicates? It indicates
Ma'am.
natural numbers. Very good. So whole numbers, in that we have 0 along with the natural number. Observe here what we have, 0 along with the collection of natural numbers. So 0 along with collection of natural numbers means what you can write here. So all natural numbers are included in whole numbers. All natural numbers are included in whole numbers. Is it true or false?
True,
True,
ma'am.
ma'am.
No, ma'am.
True. Now, just observe the first two number lines only. I am going to ask question only from the first two number lines. Can I tell all whole numbers are natural numbers?
No, ma'am.
No, ma'am.
No, ma'am. No,
Why?
ma'am.
What is the reason?
Ma'am, because the whole numbers
Whole
has
num
zero and natural numbers doesn't have
whole
zero,
number
ma'am.
starts with zero, ma'am. Natural number starts with one, ma'am.
Very good, children. So now 0 is present in whole numbers, but natural numbers we don't get 0. So all whole numbers are natural, not natural numbers, but all natural numbers we can call them as whole numbers. Okay, understood now? Now I'll ask you one more question. All whole numbers are integers. Can we tell all whole numbers as integers?
No,
No,
ma'am.
ma'am.
No, ma'am.
All numbers are integers. Observe the number line.
Yes, ma'am.
No,
Yes, ma'am.
no,
All
ma'am.
whole numbers present on integer number line also. If you observe the number line, all whole numbers are also present on integer number line also. So you can tell all whole numbers are integers. Is it correct or wrong?
Correct,
Correct,
ma'am.
ma'am.
So what is the statement you can write? All whole numbers are integers. Can I tell in reverse order? All integers are whole numbers.
No, ma'am.
All integers are whole numbers. Is it correct or wrong?
Wrong, ma'am.
No,
Why it is,
ma'am.
why it is wrong?
Because integers consist have negative integers in numbers doesn't mean.
Yes. So integers consist of negative numbers, but whole numbers do not have negative numbers. So therefore, we cannot say all integers are whole numbers, but we can tell all whole numbers are integers. Okay? Now one more
Yes, ma'am.
statement. All natural numbers are integers. Can we tell all natural numbers are integers?
No, ma'am.
No, ma'am.
Observe the number line. Observe
Yes,
the
Yes,
number
ma'am.
ma'am.
line.
Yes, ma'am. Yes, ma'am.
All natural numbers are integers. Observe the number line. All natural numbers are present
Yes,
even in
ma'am.
integers. So all
Yes,
natural
ma'am.
numbers are. Can you call all integers as natural numbers?
No, ma'am.
No, very good. So here, this is how you get questions in NMMS exam, children. So you should understand this. Whenever you get questions like that, first you should draw number line and understand whether whole numbers include natural numbers or integers. So all that you can get it clear once you draw number lines neatly in your book. Understood? So here whatever we have discussed, natural number, whole numbers and integers, here all these numbers, we are not using any decimal point in this. If you observe carefully, we are not using any decimal part in this, or we are not dividing any number with the other number. So all numbers are written on a whole. So this are, we call it as the natural numbers, whole numbers and integers. And the next type of number that we are going to discuss is about the rational numbers. Next what we have, that is rational numbers. We'll discuss now about rational numbers. I think all of you are clear with the natural numbers, whole numbers and integers, or still do you
Yes,
have any
ma'am.
doubts in?
No, ma'am.
Okay, so now whatever the properties you have learnt for integers like commutative property, associative property, distributive property, over addition and multiplication, all that properties you will get again in rational numbers also. Okay, so if you take any two rational numbers, you can check for it closure property of addition and multiplication and subtraction, and also you can check for the commutative property of addition and subtraction, multiplication and division, and also you can check for the associative property, and also you can check for the distributive property. In this also you will be getting additive identity, additive inverse, and also you will be getting about multiplicative identity and also multiplicative inverse. And that multiplicative inverse we also call it as the reciprocal of that given rational number. So these are all some of the properties about the rational numbers you are going to study in this chapter. Before going to learn about all the properties, we'll see now what is rational number. So a rational number is a number which can be written in the form of P by Q. So that we call it as rational number. A number, a number which can be written, a number which can be written, a number which can be written in the form of, in the form of P by Q, in the form of P by Q, where P and Q, where P and Q are integers. P and Q are integers, and one more condition you should know, children, and Q should not be equal to 0. Q should not be equal to 0. So it is called a rational number. It's called a rational number. Rational number. So you have learnt about this rational numbers in your 7th standard, and don't get confused with this rational number, children. If you know perfectly about fractions, you can understand the concept of rational numbers very easily. So how you are writing fractions, numerator by denominator, in the same way you will write fractions also. You can get any number, any digit, you can write it in numerator, or any digit you can write it in the denominator. So this is how you define rational number. So rational number is a number which can be written in the form of P by Q, where P and Q are integers and Q not equal to 0 is called a rational number. Now example you can write for this, any number you can write. For example, you will write it as 2 by 3 or minus 7 by 5 or 8 by minus 9. If you observe the rational numbers I have written, numerator and denominator both are integers and denominator is not equal to 0. You cannot write like 5 by 0 as an integer. It is not a rational number. It is not a rational number. So why it is not a rational number? 5 by 0 is not a rational number. What is the reason?
QE QE not equals to 0, ma'am.
Yes, Q should not be equal to 0, but here Q is equal to 0, so therefore it is not a rational number. And if you observe the above examples, here 2 and 3 both are integers, minus 7 by 5 both are integers, 8 by minus 9 again it is again an integer, or you can also write it as minus 19 by minus 25. This is again an integer. Both numerator and denominators are integers, and again it is a rational number. And when you are writing like that, minus 19 by minus 25, both minus sign you can cancel, and you are left with 19 by 25 only. Understood? This is how we represent rational number. All of you understood about this rational number, children?
Yes, ma'am. Yes, ma'am.
Okay. So this is all about the definition of rational numbers. So whatever we have discussed today, so that is all the definition of rational numbers. Okay. So we'll discuss one property based on this rational number, and we'll continue the properties of rational numbers in the next class. Okay, children. So first property, next heading you write down properties of rational numbers. Properties of rational numbers.
Ma'am, in notes should write, ma'am.
Yes, in notes only. After writing that unit test, you should write this point.
Yes, ma'am.
If you are still writing unit test, just leave some pages, 2 or 3 pages, you leave it for unit test and then you can write this. And unit test, don't write all questions one side, answers one side. You should write both question and answer. You should write first question and you should write its answer. Second question, write its answer. I've seen in your pre-test and post-test papers, simply you have copied all the key answers and you have written the test. So you should not do like that. You should write question and after that question you should write the answer. If I see in any notes, first all questions and then all the answers, I'll just tear that pages. You should write neatly how I tell you to write and put margins neatly in your maths notes if you are using unrolled notes. Okay, children. So first one is about closure property. So closure property, suppose if you are taking any two rational numbers, closure property, closure property for rational numbers. So if for any two rational numbers, for any two rational numbers, rational numbers A and B. We are taking any two rational numbers A and B. Here don't get confused A and B with P and Q. P and Q are just like the numerator and denominator of a rational number. A and B are two different rational numbers. Then if you are doing addition, for addition, if you are doing, then A plus B is also a rational number. A plus B is also a rational number. And if you are doing example, what you can write, suppose you can take A value anything, A and B value anything you can take. So what you will take for A and B, suppose A value you are taking it as 4 by 7 and B value you take it as 6 by 11. So what is the LCM you get here? 7 and 11, what is the LCM?
77, ma'am.
77, very good. So how you add this 4 by 7 and 6 by 11?
Ma'am, denominator should 7 into 11 equals 77. 4 into 11 equals
Yes, 44 plus 7 are 42. So if you add both, what you are getting? 44 plus 42, 86 by 77. So 86 by 77, is it a rational number? Is it a rational number? Is it in the form of P by Q?
yes,
Yes,
ma'am.
ma'am.
Yes. So here 77 is a rational number. Is a rational number. So what you will write if it is a rational number? Rational numbers are closed under addition. Therefore, rational numbers are closed under addition. the same way, can you do it with subtraction? Subtraction. You can take A and B any numbers. A value you can take it as minus 3 by 8 and B value you can take it as 5 by 7 minus 5 by 7. So what you get A minus B, or you can write minus 3 by 8 minus of minus 5 by 7. So what you get this minus 3 by 8 minus of minus means it is plus 5 by 7. Now what is the LCM you get for 8 and 7? 8 and 7, what is the LCM? 50?
56, ma'am.
So here 3 are multiplying with 7 and 5 are multiplying with 8. So what you get 3 sevens are 21 plus 5 eights are 40. Now if you do 40 minus 21, what you get?
19, ma'am.
19 by 56 you are getting. Is it a rational number? 19 by 56, is it a rational number?
Yes, ma'am.
Yes. 19 by 56 is a rational number. Is a rational number. So what you will write? What you will write the conclusion? Rational numbers are closed under subtraction. Therefore, rational numbers are closed under subtraction. Closed under subtraction. What can you write about multiplication in the same way? Write with multiplication. Multiplication for this A value you can take it as 4 by 5 and B value you can take it as minus 6 by 11. Now what you get A into B? 4 by 5 into minus 6 by 11. What do you get if you multiply these two? What is 4 by 5 into minus 6 by 11? Are you doing, children? What do you get? So this is minus 24 by 55. Is it a rational number? Minus 24 by 55. Is it a rational number?
Yes, ma'am.
Yes, ma'am.
Yes. So minus 24 by 55 is a rational number. So what you can write for this?
Closed under
What?
multiplication, ma'am.
Very good. So rational numbers are closed under multiplication. Rational numbers are closed under multiplication. Rational numbers are closed under multiplication. Okay. So next, one more step is remaining. So that is division. So for division, how do you check this division? You should take a rational number, like we'll take minus 5 by 3, and B will take it as 2 by 5. Now what you get, A divided by B. So A divided by B, we can write it as minus 5 by 3 divided by 2 by 5. And every time you should remember, children, whenever you get division symbol, you should change them and write it reciprocal. So what you get, 2 by 5 can be written as 5 by 2. 5 minus 25 by 3 to the 6. Do you get the rational number here? Minus 25 by 6. Is it a rational number?
Yes, ma'am.
Yes. So what you'll write? Minus 25 by 6 is a rational number. So what conclusion you'll write? Conclusion what you should write for this?
Rational
Close.
number division.
Rational numbers are closed and rational numbers are closed under division. Closed under division. Understood, children? So today what we have discussed is about the properties of rational numbers. In that first property we have discussed today, closure property. And for this closure property, what we have taken in rational numbers A and B. Is A plus B, subtraction, that is A minus B, multiplication, that is A into B, and also we have checked for division. And in all four cases what we have seen, rational numbers are closed under addition, subtraction, multiplication and division. So what does this closed under means? If you add any two rational numbers, if you subtract any two rational numbers, or if you multiply any two rational numbers, or if you divide any two rational numbers, the result that we are getting is again a rational number only. Understood? So this is about the rational numbers. But one more thing in this, if we are taking instead of B here, instead of B equal to 2 by 5, if we take in place of B as 0, if you write in place of B as 0, suppose if you write A is equals to some rational number minus 5 by 3, and B value if you write it as 0, then in such case we say rational numbers are, you cannot divide any two rational numbers, that is A divided by 0, B what you get here, that is equal to minus 5 by 3 divided by 0. So minus divide 5 by 3 divided by 0 means from this what you get. So here we are not getting a rational number which is in the form of p by q. So we can say that rational numbers are not closed under division. They are closed under multiplication, but they are not closed under division. So last one property itself, we should just write it carefully, children. Rational numbers are not closed under division. Rational numbers are closed under addition, closed under subtraction, and they are closed under multiplication, but they are not closed under division. This one property you should remember. Okay, so this is all about the first property, that is commutative closure property of rational numbers. So this, whatever the notes we have discussed today, or everything I have uploaded in the study material. So all of you can go through that and write all these points neatly in your maths notes, and you should write the chapter heading as chapter number 2, rational numbers. Write neatly, chapter heading should be ready. And, some notes when I corrected, I found that you have not written even the chapter name neatly in capital letters also. You have written in small letters only. So whenever you are starting any chapter, write neatly in capital letters only, rational numbers, or write differently. So it should be visible that if anybody see your homework also, they should understand that you have started your new chapter from this page. That you should start writing rational numbers in new pages. Chapter number 2, chapter name, rational numbers, and write all the points that we have discussed today in your math activity. That you should complete the test that I have uploaded in the section based on playing with numbers. Is it clear, children? So, if you have any doubt regarding today's class, you can let me know.
Ma'am, number system